Okay, today we're going to look at 19.2 and we're going to do the second part, kind of putting everything together that we've done so far. So, in the previous lesson, you learned how things shifted to the left or right or moved up and down depending on changing our h or our k. And two lessons ago, you learned what happens with the a that's out front. So, we're going to kind of put things all together and be able to graph if we have any equation in this vertex form. Remember, this is vertex form. If we have any quadratic in a vertex form, we will go through a process to quickly and easily graph that. So first, just think about how these numbers change. If a is bigger, it makes that graph skinnier. All right, it's that stretch. If a is between 1 and 0, it's compressing, it's making that graph wider. If there's a negative in front, it makes the graph open downward, so it flips it upside down. All right, and remember, if we change h, if it changes that number inside the parentheses, it will move it either left or right. Just be careful that we are looking at it, there's that minus sign in there, it's minus h, so you have to be very careful with your negative pieces on this. We also had k at the end, which moved our graph up or down. All right, our general steps for a quadratic that is in vertex form. We are going to identify the vertex h comma k. So h is that number in there. That's the x value of the vertex. Be careful of that negative. It's always x minus h. So if it was x minus 2, h would be 2. If it was x plus 2, h would be negative 2. All right, and then k is the y value of the vertex. So we find our h comma k, which is our vertex. We're going to then find 2 points on the side of on one side, and we know by symmetry that it will have the exact same points on the other side of the axis of symmetry. All right, we are going to find those 2 points, and then we are going to plug our values in and calculate it to get that into the table, plot the points, and then graph it. All right, vertex form, h comma k is the vertex. The axis of symmetry is always at h. We are going to graph it by identifying the vertex, determine if it opens up or down, and find some points, and then sketch it. So first, vertex. For this, remember this is x minus negative 1. We can rewrite that. So h is negative 1. H is going to be, it's going to have the opposite sign essentially of whatever is inside the parentheses. K is negative 2. It's minus 2 at the end. K is negative 2. So my vertex is negative 1, negative 2. H is the x value, k is the y value. All right, so I'm going to put my vertex, negative 1, negative 2, right in the center here. And I'm going to do 2 points on either side. So negative 1, if we go backwards, negative 2, negative 3, and go the other way, 0 and 1. All right, so now I'm going to take these values that I have for my table, I can plug them in to find my other points of the graph. Okay, I'm going to take 0 and plug it in and solve for my output, my y. So if I have negative 3 and then 0 plus 1 squared minus 2, we can find out that value. All right, so 0 plus 1 is 1. 1 squared is 1. 1 times negative 3 is negative 3. Negative 3 minus 2 is negative 5. All right, put 1 in, so negative 3, and then 1 plus 1 squared minus 2. 1 plus 1 is 2, 2 squared is 4, 4 times negative 3 is negative 12, minus 2 is negative 14. All right, I know that was a little quick, but you can follow those steps through that. All right, now we could go through and plug in negative 2 and negative 3, but because I know it's a quadratic, I know it has to have symmetry, so I can take these numbers and put them up here. I know it will be negative 5. I know it will be negative 14. As long as I am careful with my multiplication and order of operations, it should reflect and have that repeating pattern from what we've seen before. All right, now plot our points, and we should know just by looking at the different part, it's going to be opening down, it's negative. It's going to be skinny because that's a negative 3. It should be very skinny. The plus 1 inside means it should move to the left 1, and the minus 2 means it should move down 2. So we can kind of think of where it should be based off of all those things. But plot my points. Negative 1, negative 2, 0, negative 5, 1, negative 14, 2, or negative 2 and negative 5, negative 3 and negative 14. All right, sketch the curve. And I didn't draw it great, but we get the general idea. We do have axis of symmetry. It does look very skinny. It is pointing down like it should, and it did move over left 1 and down 2. All right, next example. Thinking about what we have up front, it's got a 2 in front. It's going to be skinnier. It's got x minus 1, so h is 1. H is the opposite of whatever we have in there. Since we have x minus 1, h is positive 1. K is negative 7. So my vertex is 1, 7. All right, I'm going to put that into my table, xy. Put that in the center. Sorry, that's 1, negative 7. 1, negative 7. I want to do 2 points on either side, so I can go 0 and negative 1, and 2 and 3. All right, plug it in, plug some values in. So I'm just going to put 2 in. 2 times 2 minus 1 squared minus 7. So 2 minus 1 is 1. 1 squared is 1. Times 2 is 2. 2 minus 7 is negative 5. All right, and do the same with 3. 2 times 3 minus 1 squared minus 7. So 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 7 is negative 1. We should have a repeating value, so this should be negative 5, and this should be negative 1. Okay, knowing from the point, it should have moved down 7 because of the k. It should have moved right 1, and it should be skinnier because of the 2 out front. So plotting those points. Now we're going to plot our points, and we are going to graph this. So be careful on this graph, because if you look, each line goes up by 1.5, and we might have to be a little careful with where we place things. All right, so we go to 1 and negative 7, so it should be about there. That's my vertex. 2 goes to negative 5, so 1.5, 2, -5. Should be a little past that. 3 is -1. So 3 and -1. That side should look like that. Then we have 0 and -5. About there. And -1, -1. Around there. Okay, so it did move down 7. It moved right 1. It does look skinnier than what the original just x squared parent function would look like. All right, you got 2 year turns, so go ahead, get some practice in there. Think about what it's going to look like. I will let you pause the video, fill in your information, and then you can graph it. Okay, so you can check your answers on here. They should look something like this. We found our vertex h comma k, so it was 2 and 4, and because it was +3, that made it -3 for our h, and -1 for our k. Put that into the vertex. Here our h was 2 and k equaled 4. 2 points on either side for both of them, and then just plug in those numbers, calculate it, and graph it. So you do have a couple of practice problems that are assigned. So get those taken care of, and I'll see you next week.